So now we're moving to session 3. What do we need to do about climate change? So we're going to have four speakers, and each of you will have, the people in the room will have 15 minutes in total, 12 minutes plus 3 minutes of questions, and then then the online speaker will have 20 minutes plus 5 minutes of questions. And our first speaker is Rachel Warren. Rachel is a professor of global change and environmental biology at the Tyndall Centre. She's really been a big contributor to the IPCC process that Jean Palutikoff talked about with us, and has made many research contributions in terms of the quantification of climate change impacts and what can be done to avoid them. And she has a strong interest in biodiversity. Rachel.
Thank you, Robert. So first of all, thank you very much to Tim and the Climatic Research Unit for the invitation to speak today. So much of my research during my time at UEA has focused on the quantification of climate change risks. And much that I've done actually would not have been possible without my collaboration with Tim Osborne, because most of the modelling that I have done has used the outputs of the pattern scaling projections from ClimGen, because the global circulation models are too coarse to be used directly in the projection of climate change risks at regional and local scale. So thank you to Tim for that long-standing collaboration. So as Robert mentioned, I've had a long-standing role in the Intergovernmental Panel on Climate Change. And I'm going to start with some statements from the 6th Assessment Report, in which I was a lead author, which really explain why this work on quantifying risks is so important. So if we don't quantify the risks of global warming at different levels, governments don't have evidence to know what the benefit is of performing climate change mitigation and performing climate change adaptation actions. And so, in particular with mitigation, it's critical, given that mitigation costs money, to have evidence to show that there are large benefits. And so I've been involved in doing that for many years. The 6th assessment has looked at the consequences of exceeding 1.5 degrees and found that even temporary excesses over 1.5 degrees result in severe and potentially irreversible impacts, particularly in natural systems, and that every small increase beyond 1.5 degrees results in escalating losses and damages. In this talk, I'm going to cover 3 scales: the global scale, the national scale, and also the UK scale. Actually, I won't be covering the UK scale, but I'm just mentioning that I'm also involved in the work at the UK scale through the OpenClim project, which some of the students here have just presented so well on. Okay, so the global scale. So I've been involved in the embers process. Now, these diagrams are called embers because of their glowing colours, and they show how the risks of global warming accrue with every 0.5 degree increase in temperature, basically, as you can see here. So I've been involved in this since the 5th assessment and led it in the SR 1.5 report and in AR6. And in this process, we classify risk into 5 reasons for concern. We set criteria to communicate high or very high risk or moderate risk. Those criteria are well defined. And the reason that we do this is so that we can put all of the information that has been accrued across the whole of the assessment report into a single diagram for policymakers to look at. They can compare between different types of risk, for example, unique and threatened systems or extreme weather events, And then it is also possible to make a comparison between IPCC assessments to see how understanding has changed over time. And there is some subjectivity in this process, and in order to quell some criticism that the process received, we introduced a formal expert elicitation in the 6th assessment. So when we construct these embers, this is a team effort, a large team effort, we differentiate between when there is or is not impacts that are detectable and attributable to climate change as our transition from white to yellow. And then we have criteria defining severe and widespread impacts or very high risks where the adaptation limits are being approached. And our impacts are defined as those which have occurred in the past. And when we speak of risks, they are those which we project will occur in the future. So this is the latest diagram from the 6th assessment. And what you can see is that they are put opposite the scenarios used by Working Group 1 of the IPCC to project possible future global warming, and enables the policymaker to see very clearly how achieving the Paris Agreement, as in the two blue curves, SSP 1, 1.9 and 2.6, keeps the risk level in the moderate or high level in all of these embers. Now, unfortunately, it still is in the high level for extreme weather events and approaching the very high level from unique and threatened systems. So this really outlines how even the Paris Agreement is not going to prevent all of the risks. But you can see very clearly how much, very, very much greater the risks are if the Paris Agreement is not achieved. And in particular, 2 risks associated with near-term warming were identified in AR6, as I've just mentioned, the extreme weather and the unique and threatened systems. So most of the work that I've done at UEA, as I said, has been on quantifying climate risks using the outputs of pattern scaling. And in the 4th assessment of the IPCC, I contributed to the ecosystems chapter performing a meta-analysis of the risks climate change poses to ecosystems by synthesizing 100 publications. And actually it was that work which underpinned the statement that Jean showed earlier about 20 to 30% of species assessed so far being at risk of extinction between 1.5 and 2.5. And in that chapter we noticed that all of those 100 papers had used different climate scenarios, different assumptions and so on. So Jeff Price and myself got together with James Cook University and Jeff initiated the Wallace Initiative, which the aim of which was to conduct a harmonized assessment of the risks global climate change poses to biodiversity. And hence the Wallace Initiative was born, enabling one to compare how, here with the Great Crested Newt, between 1.5 and 3 degrees of warming, the climatically suitable range shrinks dramatically. And this was repeated for 125,000 species using 21 alternative regional climate model projections, which pattern scaled for us by Tim Osborne. And here you can see the resultant paper in Science showing the climatic range loss in over 30,000 insects, showing that at 3 degrees warming that basically over half of insects are losing at least half their range, as compared with much lower values at 2 and 1.5 degrees. But also notice that the level of risk at 1.5 degrees is dramatically less than the risk at 2 degrees. This is actually teasing out the difference between those 1.5 and 2 levels in the Paris Agreement. We repeated this for all of the other taxa, well, not all of them, but plants, vertebrates, and we found similar trends with warming. Note the error bars due to the errors in uncertainty in regional climate projection, and found that limiting warming to 1.5 degrees avoids half the risks associated with 2 for plants and animals and 2/3 for insects. And we co-produced some research with World Wildlife Fund looking at the extirpation risks that were associated with those losses of geographic range, and showed, as it happens, a linear relationship between global warming and extirpation risks in the World Wildlife Fund priority places. And the 2 lines here, with and without adaptation, the with adaptation is if you could create corridors that would allow species to disperse. And similarly, we looked at how the refugia would decline with warming. These are the refugia of the places where most of the species are still present despite climate change, and again showed a pronounced decrease with warming. Much of the other work that I have done at UEA has been interdisciplinary, and in particular co-producing research with the Department of Business and Industrial Strategy. This is an example showing risks to India. This is an infographic produced by Asha Mins and Renee in the Tyndall Centre to showcase the findings of the team on risks of heat stress, coastal flooding, drought, fluvial flooding, and crop yields at different levels of warming. And so BEIS funded this research in order to assist their work in the preparation for the UN FCCC negotiation process. And so you can see the biodiversity work was also teased out for India. We looked at 6 countries overall in this. I should say this is very much a team effort. It couldn't have been done without the likes of Helen Hay, Nicole Forstenhausler, and many others, some of whom may be in the room. And basically, we looked at how the risks accrued with warming, how did that vary with either a constant population or population evolving, as in the second shared socioeconomic pathway, looked out to 2100, and we also looked at the land cover that is exposed to drought. And so this is a paper led by Jeff Price, looking at the quantification of agricultural drought, basically, in the 6 countries. And so the different lines, the blue is agricultural land, the green natural land, and the yellow urban, basically showing the slightly different shapes of the curves in different countries. And we're using the SPEI index, which was so aptly explained by one of the students earlier. And what you can see is these extremely large increases in drought. We also calculated population exposure to drought, highlighting again dramatic increases with warming, leading to some key messages. These are just some examples which were co-produced with BEIS. So limiting global warming to 1.5 degrees reduces crop yield in Ethiopia by over a half. And then Katie Jenkins et al. Went on to look at the effects, how much would that contribute to GDP loss in the country, and also powerful statements about increasing drought risk in Egypt and the benefits of limiting warming to 1.5 degrees. And similarly, in Brazil and China, that even in the 1.5 degree warming scenario, more than 50% of agricultural areas are expected to be exposed to severe droughts of a year or longer. Whereas in Ghana and India, that happens at a slightly higher level of warming. I've also worked with economists to look at the global aggregate damages in 2100, in particular working with Chris Hope, and also Katie Jenkins, who is a member of the Tyndall Centre today, and we looked at using a model called Page-09, which is the same one that was used in the Stern review, looking at the global aggregate damages and showing that 92% of the losses would be avoided if we limited warming to 1.5 and not 4 degrees. And that actually resulted in one of a major pension fund deciding to decarbonise. So to conclude, all of this research over the years has underpinned how every small increase in warming beyond 1.5 degrees results in escalating physical losses and also economic damages. And near-term actions that limit global warming to close to 1.5 degrees would substantially reduce those losses to both human systems and ecosystems, but unfortunately cannot eliminate them all. So thank you for listening.
Oops. Right, okay. Questions? At the back.
Thanks, Rachel. That's a sobering assessment. I've got a question. You separated extreme events from singular events. Could you give an example of what you mean by singular events?
Right, okay, so I didn't have time to explain the reasons for concern in great detail, but yeah, if we go back to this figure here, what you can see, oops. So basically extreme weather events are what you think they are, the floods, droughts, and hurricanes and typhoons. And the large-scale singular events refer to what you may commonly refer to as tipping points in the Earth system. So these are events that usually have a threshold, so the Amazon dieback, the melting of the Greenland and Antarctic ice sheets, the potential collapse of the AMOC and so on. So that's the difference there.
Any other questions, please?
Hi, thank you a lot for your talk. So you spoke about, for instance, insects as species that lose their climatic range. And I was wondering whether you looked at other factors that also determine the habitat range of those species, for instance, land use or so?
Right, absolutely. So in other work that Jeff Price and myself are doing, we are combining land use and climate change into a holistic assessment and also folding in population projections as well. And so Jeff has a paper coming out on the projections for natural capital loss as a result of combined climate and land use change. So obviously, historically, land use change has been the primary driver of biodiversity loss, but basically we're expecting climate change to overtake that during this century. But clearly the two very much act in tandem. And of course, with insects, there's the whole role of pesticides and insecticides as well, which have also played a key role in the observed losses of insects. But we are already seeing insect declines in areas in the middle of rainforests far from where people are using pesticides. So that is a possible indicator of already an impact of climate change away from other human influences.
Do we have an online question? Okay, we'll take it then, and then this is the last question.
Thank you. Yes, we have an online question from Jill Malin. She's asking if your assessments also considered the marine environment.
Right, so there has been a parallel process looking at the marine environment. So there is a well-known modelling enterprise called the Sea Around Us, and then there is a major research effort led by William Chung at UBC, University of British Columbia, looking at the marine environment. And so basically, they were doing an excellent job, so we didn't want to invent the wheel. It's actually quite difficult for us to apply our techniques to the marine environment, because in the marine environment, you've got entirely different variables that you need to look at, like salinity and changes in ocean currents. So it's actually a completely different ball game required. Whereas in the terrestrial environment, is where we have all historically worked. So the marine environment is very important. And so when I lead, large teams to assess things, of course, I ensure that the marine environment is represented, and so we have all of the marine experts contributed to the burning embers process in the IPCC, for example. So the answer is yes, marine is absolutely critical, but somewhat beyond the scope of our expertise.
Okay. Thank you very much, Rachel.